Hey everyone, let's take a look at number 6 here in section 7.5. We're going to evaluate the following integral here. Of course, we're going to use partial fraction decomposition. Of course, don't forget your constant C as they explain there. Um, let's see how we're going to expand this out and write out its partial fraction decomposition. Notice the degree of the numerator is 1. The degree of the denominator, if we were to multiply this out, we got 2 here, degree 2, degree 1 would be fourth degree, right? If I expanded this all the way out. So we're good to go ahead and look at the partial fraction decomposition. Since the denominator is factored for us, we know that, first of all, from x squared, that's a linear factor, right? X is really x plus or minus 0, I guess. Quantity squared is what we're looking at, right? So it's a linear factor. So there's 2 of them though. So I'll have a over x plus b over x squared. There's one x minus 1 linear factor, right? So I'll have that fraction. And then one linear factor here, or one fraction here from the linear factor x minus 3. And so I need to find the values of a, b, c, and d. So first thing is to do that is to multiply as we do right by the least common denominator, which is of course this right down here. And when I do that, I get 17x plus 6 here. Here, one of the x's cancels with this x squared, and I'm left with a times these factors. When I multiply it times this fraction, the x squares cancel, right? And I'm left with x minus 1 times x minus 3. And so on. Here, I'll cancel the x minus 1s, leaving the x squared times x minus 3. And then the last one, the x minus 3, will cancel. Okay, so that's a lot to write. And now how can we find the values of a, b, c, and d? Well, I've got a couple of shortcuts. First of all, notice I can choose x to be 0. Right? In this equation here, I could let x be 0. Obviously, we could not do it up here, but the values for A, B, C, and D we want to work for this problem. We also want to work down here for all values of x, which will include the values of x that we are restricted to up here. But here we can plug in, right? So x equals 0 is one of those values. When I plug in 0 on this side, of course, I just get 6, right? 17 times 0 is 0 plus 6. And then notice this uh, whole term here will be 0 because of the x. So will this term, right? 0 squared is 0. And same here. All we're left with is this term. And if I plug in 0, I get negative 1 times negative 3, which gives me positive 3 times b. Therefore, b must be 2. When I plug in x equal 1, that's the other thing I can plug into, right? The other shortcut. I'll get 17 plus 6, which is 23. And this term will be 0. This term will be 0. And the last term will be 0, right? If I plug in x equal 1. This term will not, though, right? I'll get c times 1 squared is 1. 1 minus 3 is negative 2. So I'll get c times negative 2 or negative 2c. So if I solve for c, I get c as negative 23 halves. And then x equal 3, right? Again, right here, I can plug that in. 17 times 3 is 51. This is 0 now. If I plug in x equal 3, this one is, and this one here is, this one is not. I get 3 squared, which is 9. 3 minus 1 is 2. So I get 18d. 51 plus 6 is 57. So I get 57 18ths for d, which is simplified down to 19 sixths. Okay. So I know B, C, and D. Now, how can I find A? Well, you could replace B, C, and D with those values and expand all this out and use the method of undetermined coefficients to solve for A. Okay, that's going to take a little bit of work, I think, to expand all this out and combine like terms. And plus, we've got these fractional stuff, which a little bothersome. I'm going to show you another way that you can do it. If there's only one other unknown at this point that you need, which is true, we just need to know the value of A, right? We got B, C, and D. Then after plugging in x equals 0, 1, and 3, you can plug in any other value of x into this equation and plug in the values of b, c, and d, and you'll have an equation that you can solve for a. So any other value of x other than these three that we've chosen, 0, 1, or 3. So what am I going to choose? I'm going to choose 2. Again, it could be any other value. I'll choose something simple like 2. So when I plug in 2, 17 times 2 is 34 plus 6. And now if I plug in 2 for x here, I'll get 2 times a. 2 minus 1 is 1. 2 minus 3 is -1. So when I multiply all these together, what will I get? -2a. -2a. Now, over here, I'll get b. Plugging in 2 minus 1 is 1. And b, of course, is 2. So I'm replacing b with 2. And then 2 minus 3 is -1. And then c, remember c was the -23 halves. Plug in x is 2. 2 squared is 4. 2 minus 3, -1. And then plus d, d is 19/6. 2 squared is 4. 2 minus 1 is 1. Multiply all these out, and I get the following, right, for each of these. And then I just use your calculator if you have to combine these values here. And then I can solve for a by added 2a to this side. Subtracted 40 from 170 over 3 gives me 50 thirds. And then dividing by 2 gives me the 25 thirds. So after some arithmetic there, we get our value. So that's a little bit shorter of a method to find the value of a. Okay, so all this work and how much calculus have we done? 0, right? This is all pre-calculus. But now I know the partial fraction decomposition. I take these values of a, b, c, and d and replace them here, 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 and here. And when I integrate this, I'm now integrating those things. And I've done that here, right? A was 25 thirds, B was 2, C was -23 halves, and D was 19/6. And now we can find the antiderivative of each one of these. So this one's pretty easy, right? 25 thirds is a constant multiple. Antiderivative 1 over x is just the natural log absolute value of x. So I get 25 thirds times that. This one, just note, is the same as 2 times x to the -2. So if I integrate that by the power rule, add 1 to -2 gives me -1 divided by -1. So this is -2 x to the -1, or -2 divided by x. So there's the antiderivative there. And then here, the -23 halves can come out. And then if we let u be x minus 1, du is dx, I get 1 over u. The antiderivative 1 over u is the natural log absolute value of u. So I get -23 halves, natural log of x minus 1. And then very similar, I hope you've seen this before, this antiderivative is 19/6 natural log absolute value of x minus 3. Again, your polynomials might be slightly different than this, but it should look very similar to this in terms of the process. Okay, so long one is a page and a half, right, of work, but that's what it takes on some of these partial fraction decomposition problems. Okay, lots of fun. Hope this helps.